Hello, algebra students. We are going to look at more of these systems of inequalities. We're going to be graphing the solutions. That is, we're going to graph the region of the plane where both inequalities are true. And you see the first one we did in class is still there. I'm getting better at this shading now with this transparency, and we'll see if it works better and should make the video shorter. So let's look at number 2. Remember, for each of the inequalities, we will shade the region where it is true, and then when the overlap of the two of them will be the region where both are true. So let's get started. Both of these in number 2 are in slope-intercept form already. So we are ready to graph them. So we'll graph the lines and then we'll shade the right region. So for the first one, that's this one, its intercept is +1. Okay, so we graph that point. And the slope is 1/2. So the rise over run is 1/2. A rise of 1, a run of 2 gets us to there and gets us our second point. And then we connect those, and we use a dashed line here, right? Because it's less than. It's not less than or equal. So dashed line, okay. And let's go ahead and shade that. So we make this fatter and we make it transparent. And so which side do we shade? We shade below because this one is less than, right? So here we go. So I think that we can get this shaded. Okay, so that's the region where that one is true. So let's look at the other one. We will graph it. And it's this one. The y-intercept is -2, giving us a point right there. The slope is +2, so that will give us our other point. Rise over run is 2/1. A rise of 2, a run of 1 gets us to that point right there, which we will color in. And now this one is a solid line because that's greater than or equal. Okay, so connect those with a solid line. Okay, so now we have to shade that one, and we're going to shade it. Which side do we shade it? Above, because this one is greater than or equal specifically, but it's greater than, so we shade above the green one. So that's going to look like that. Get that shaded in. So now they're both shaded, and we are looking for the overlap, and the overlap is the darker area, which is, let's see, yeah, that's not what I want, sorry. You know, this area here, oh, wrong way. This area right here, we could right. Try to outline it, but that's not working very well. But you can see the area that's darker where the overlap. Okay, so that's that one. Okay, let's look at the next one. Okay, this one's a little different, and it's a good thing. It's nice to have some problems like this. We have this first inequality is kind of funny. It does not even have y in it, right? Just x. So what do we make of that? We've got to graph that line. X equals -2 is the line we're going to graph, which will be the boundary of our region of the plane. So hopefully you recall, how do you graph that? Well, I think of it this way. If x is -2, I may have said 2 a while ago, -2, that means it doesn't matter what y is, x is just always -2. So that's a vertical line right here on x -2. You see anywhere up and down that line, x is -2. Okay, so we make it solid, which I did because it's greater than or equal. Okay, so the other one is in slope-intercept form. Well, first let's go ahead and shade once we made the line. Which side do we shade? That one. Um, it says greater than or equal to -2. So everywhere where x is larger than -2, so that's to the right. See, the up or down idea does not work when there's no y in the inequality. There's only x. So we have to say, well, is it to the right or the left that we want to shade? And we want to shade to the right because x is always greater than -2. So let's shade that. Everything to the right. Okay. So now we'll do the other line. And it's already in slope-intercept form. It's going to be the boundary line of our other region, of course. The y-intercept is 2, so that gets us a point. The slope is -1/2, so the rise over run is -1/2, or 1/2. Okay, it could be either -1/2 or 1/2. We'll say it's -1/2. So the rise is -1, the run is 2, gets us to right there. And that's our point. And this one is going to be a solid line because that is less than or greater than or equal. So we make a solid line. Oh, wrong place. Okay, pretty close. So we're going to shade which side of it? It's greater than, so we shade above. Okay, so let's do that. Above that line. So there it is. And we can see the overlap region is where it's darker, and that's where both are true. Okay, so I think we only really need to look at one more of these. This next one is a good example because these inequalities are not in slope-intercept form. So we will have to put them in slope-intercept form. Okay, so we'll try to make ourselves a little more room so we can do that. Oh, I keep drawing on it. Oh, why is it doing that? Don't like that. There we go. That's what I want. Okay, we cut one of them off. Can't do that. So the first one, 2x minus y is greater than 3. Okay, we need it in slope-intercept form. So we subtract 2x from both sides first. Okay, so on the left, we just have negative y greater than negative 2x plus 3. Remember, you cannot combine 3 and 2x in any way. Those are not like terms, right? And so, like we said in some of the classes, well, 3 minus 2x, what is that? And the answer is it's just 3 minus 2x, which is what we have here, but we put it in the other order. Instead of 3 minus 2x, we're saying negative 2x plus 3, but you don't combine them is the point. Okay, so we're almost done. It's not in slope-intercept form, though, because this is negative y over here, and we just want it to be y. So now we divide both sides by negative 1. And we're not going to write the sign there because we're dividing by a negative, and we have to remember what to do when we divide by a negative. Divide each term by that negative 1, and then we realize, yes, we need to reverse that. So it was greater than, and it's going to become less than. Okay? And so now we go ahead and do this simplification, and we do have y on the left, and that's less than, and this just becomes positive 2x, right? And then minus 3. Okay? So that's that one. And before we graph it, let's go ahead and put the other one in slope-intercept form as well. So that's, see if we have room to do that. 3x, I'm going to sort of first put a circle around that one so we'll know that's the one we're going to graph. Okay, so the other one is 3x plus y greater than 2. And this one won't take as many steps, right? We subtract 3x from both sides, and on the left we get y, and on the right we get negative 3x plus 2, and that one's done. And we didn't have to worry about dividing by a negative or anything to flip the sign. It's done. Okay, so now we're going to graph these. We'll do the first one first, and that's the one in green. The intercept is negative 3, so that's right here. The slope is positive 2, so that means 2 over 1. So rise over run is 2 over 1. Rise of 2, run of 1 gets us to there. And now this one, let's see, this is less, it's just less than. And so we make the dashed line. So practice my dashed line skills here. Something like that. Um, let's go ahead and shade that. And which side do we shade? Remember, to decide which side to shade, we have to look not at the original inequality, but we have to look at the one we acquired. Okay, and I'm going to see what this looks like if I highlight it like that. That's the one, okay, and it's less than. So we shade below that line. So that means like this. Okay, so now let's do our other one. We got to graph it, and that's the one in red or reddish brown. Um, and the intercept is +2. So that's right here. The slope is -3. So I'll write that down this time. Rise over run. We can put the negative sign with either the 3 or the 1, which is more convenient. Either one, really. We'll go down 3. We've got some room on either side of our point, but we'll take rise of -3 or run of 1. So rise of -3, a run of 1 happens to get us to that same point, but that doesn't really matter. Okay, and those are the 2 points now. This one's also a dashed line because it's not or equal, it's just greater than, right? So we want that dashed line. Dashed line connecting them. Okay. So which side do we shade? Remember, we look at this to see which way to shade, and we shade above. So don't want it too dark, and we shade above that line. And so we see it comes out. The overlap is the darker area, which is the solution of this system of inequalities. So I hope this way of shading works better. When you do them yourself, I think shading really lightly with a sharp pencil might be the best way, especially if you have two colors. You can also eyeball it and just look at it and go, you know what, if I shade over that one and under this one, then it's going to be, this is the part that's in both. You can sort of figure it out and just shade the part that does where the overlap is. But it's kind of nice if you can shade both of them and completely. That is, shade the solution of each line of each inequality, and then have the overlap be the darker area. So either way is okay, though. So that is all. Thanks for watching. I will see you later.